Hello student, let's try to understand integrated equation for zero order reaction students. So we are going to understand what is integrated equation for zero order reaction. So dear students, what is the zero order reaction? So whenever you talk about zero order reaction, sum of power of concentration of reactant in rate lies 0. That is what student, it is the experimental. So here how can you write that is rate is equal to proportional to, suppose it is A is giving B plus C, or you simply write A is giving B. So what will be, that is reactant power, what is there student? 0. So order is going to be what student? 0. Now we have to integrate, right? We have to learn that how we can integrate, okay, the zero order reaction. So whenever integration is done student, so we write in the terms of rate. So let us try student. So reactant is going to give product student, so rate is equal to, right? So in the term of reactant we have to write minus dr student, it is very small change in the concentration of reactant, divided by dt. It will be equal to k student, and r power it will be 0. This is what is the expression of the rate law student. Now anything power 0, r power 0, that is going to be 1. R 100 power 0, its value also going to be 1. So anything power is going to be 0, it is always going to be 1. So we can write rate is equal to minus dr by dt equal to, here is k. Now we are putting the terms in different way. This is dr is equal to, it is going to be k dt. Now what we can do, we can put the sign, negative sign, in the right side student. So minus k dt. K is constant, so we cannot do the integration student. So here is dr is equal to minus k integration of dt. Student, rule is there, rule of integration, rule of integration. So when you are integrating many dr student, when many dr you are integrating, so at the end what you are going to get student, you are going to get r, okay. So this is r, and many dt you are adding, many dt you are adding, so you are going to get t. So what we can write here student after that, so this equation is going to turn out to be, that is r minus kt plus small t only, kt plus it is going to be I student, kt plus I. Of this equation is I is what? Integration constant. This is the integration constant, okay. Now this value we are writing at t is equal to 0, at t is equal to 0. So r is equal to, it is going to be what student? R naught, because time 0. So we are plugging the value, student. So at the place of r from 1, we are putting the r naught minus k. At the place of t, that will be 0 plus I. So this term will be 0. So I is equal to, it is going to be r naught, student. So this is equation number 2. Now from 1 and 2, student, you can go from 1 and 2. So from 1 and 2, so r is equal to, it is minus kt plus, at the value of I, at the place of I, it is going to be r naught. Kt you take to be this side, student. So kt is equal to, this is going to be r naught minus r. So if you are calculating rate constant, so k is equal to, it is going to be r naught minus r, it is upon going to be what, student? T. So this is the equation of rate constant for what, student? Zero order reactions, right? Now we need to draw the graph. Okay, so how can you draw the graph in term with respect to concentration versus time? We have to draw the graph. So which equation can fit on the this one, y equal to mx plus c? So equation 3 you see, student. 3. Check the equation, student. Equation number 3. So here will be r is equal to minus kt plus, it is going to be r naught. This. So if you are making the graph, student, so this is concentration of reactant, it is going to be this side, and here is, it is going to be time. This is x-axis and this is y-axis. So y-axis is taking to be the concentration and x-axis is taking to be time. M we know that is, it is slope, student. This is slope. So how much the slope, it is the going to be negative, so we can draw it like that. So slope is equal to, this is minus k. Now the another terms which you can see, which is what, student? Intercept, because c is intercept, student, intercept. So intercept will be this will be r naught. This total from 0 to this position is called intercept. So this is all about the what is, student? Graph for the zero order reaction, right? Now let's try to understand the half-life period of zero order reaction, student. So when you talk about half-life period, it implies that in what time it is going to become the half. In how much time the r is becoming r naught by 2, that we have to understand. So let's try to understand half life period of zero order reaction. Student, आ जाइए. Student, here we got the equation which we can see k is equal to, we are having k is equal to, this is the r naught minus r minus r upon, it is the t. So at half, T we have considered T1 by 2. So R is equal to, it will become what, student? R naught by 2. So from this equation you go, student, this value you put. So K is equal to R naught will be as it is. R is equal to, it is R naught by 2. Our total time is T half. You take it out, the T half this side, T1 by 2. So 2 R naught, student, minus R naught divided by 2K. So T1 by 2 is equal to R naught by 2K. So this is half-life period, student. In this time the reaction will be half. So this is what the integrated equation for zero order reaction.